Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 12th grade topic, simplifying limits. Now, if you're new to my channel, I'll be putting timecodes in for this video in the description box below, so use it to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what you see today, or even your own homework, you can always put in the comment box below, or visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. At the end of this video, I'll be linking my 12th grade playlist, in which I cover a lot more topics. So, if you're interested in that, make sure you stay tuned. This video is going to have 3 parts, so leave a like, smash subscribe, and let's get started! In my previous video, we covered how to find your limits at a point. And the first thing you want to do when you're doing that is to check for continuity at that point, which may result in one of 3 possible outcomes, one of which being your indeterminate form, your 0 over 0. And I told you, in order to tackle that outcome, the main thing you want to be focused on is simplifying your function. And there are many different ways you need to simplify functions depending on how they look. Now, if you hadn't seen that video, no worries. You can find it right up here. However, today we're going to be jumping into 3 different modes of simplification that you may need to apply when you're trying to handle your indeterminate form. Now, the simplification I'm going to be showing you today is not going to be something new because this is not going to be something that's unique to limits. You've probably done this a lot of times by now for your functions, but I want to show you that it applies to limits as well because you're going to be finding limits of functions. So this video may actually end up being more a review or a refresher for most, but it's still fine. I want you to be more familiar with how to simplify some functions that may not be terribly obvious at first glance. So the first mode that we're going to be looking at is factoring. Then we're going to be moving on to using your common denominators, and finally using your conjugates. Now, the first example we have is factoring this cubic polynomial on the top. Now, how do we know we need to factor this, that this is not going to work? Well, if you were to plug in your 3 into both top and bottom, you'll notice that you'll get 0 over 0, our indeterminate form, which lets us know that we're not done. We got work to do. We need to start simplifying this function. So now you're going to be thinking, how do I simplify this cubic polynomial on the top? Well, if you notice, there's a nice ratio in the top that you can take advantage of. So between the first and second term, you have a negative 1/3. Your coefficient, putting the 2 over each other, getting that nice ratio, you're going to have a negative 1/3. Same thing for your next 2 terms. So you have a negative 4 over 12, which is going to reduce to a negative 1/3. Because you have that same ratio, you can actually factor this by grouping. So we're going to be employing that way of factoring here. We're going to be grouping or factoring by grouping. So we can rewrite this. Actually, I'm not going to rewrite the whole thing. This is going to be a little dangerous. I recommend you write out everything. But because I have limit space, I'm not going to write out everything. I'm going to leave off the limit until the very end and then plug it back in. I'm just going to be focusing on the function here. Actually, I'm just going to be focusing on this top part. So we want to factor this. If we look at what's in common, grouping your first 2 terms, what's in common for both of them? We're going to have an x squared that's common for both. And when we factor that out, we're left with an x minus 3. Now, we have our next 2 terms. What's in common for both of them? Well, we have let's say we factor out a negative, right? A negative 4. We're left with a positive x, and we factored a negative 4, so we're left with a negative 3 here, right? And then we're going to just write this bottom here. And what happens now? Well, let's factor out what's in common on the top. So we're going to have our x minus 3, that's in common, right, for both terms, factored out, and we're left with an x squared minus 4. Right? That's how we got from here to here. And of course, just write your x minus 3 on the bottom. Next, we're going to do what? Well, let's cross out what's in common from top and bottom. X minus 3 is both places, so we're just left with an x squared minus 4, which means that our simplification, our factoring of this function here results in an x squared minus 4. We can rewrite this limit now as the limit as x goes to 3 of x squared minus 4. And if we were to try to find what this limit is at this point, check for continuity at the point. Let's plug in our 3. We're going to be having 3 squared minus 4, which is just going to be 9 minus 4, which ends up with 5. Our limit at 3 for this function is going to be 5. And that's because whenever we have the indeterminate form, it's a whole, a removable discontinuity, and we just remove that discontinuity. This function is going to be acting like this function for the entire function except at the point 3. So all we have to do is see what this would do at 3, and we'll have our limit for this function. If that confused you, I recommend you check out my video on continuity and limits, and you can see how continuity plays a role in your limits. You can check out that video right up here as well. So this was an example of how you're going to be factoring in order to simplify your function. And sometimes you're not going to be just having your quadratics. You'll have something like a cubic, or maybe something even higher than that. But factoring is still factoring. Now let's move on to our next example, in which we're going to be doing our common denominator and figuring out how that's going to help us. So for this example, we want to use our common denominator to simplify our function. Now, how do we know that we need to simplify this? How do we know that we're going to have to do that outcome? Well, if you plug in your 3, once again, checking for continuity at this point, you're going to see that you're going to get your 0 over 0, your indeterminate form, which lets us know that we need to simplify this. We need to get rid of that removable discontinuity. And this looks a little weird. And we know that this is not going to simply work by factoring like we did in our previous example. So we need something else, another tool in our toolbox. And the tool that we're going to need is going to be our common denominator. We have some fractions here, which should be an indicator that we're probably going to need some type of common denominator. So I'm going to rewrite this, and I'm not going to put the limit just like we did last time. I'm just going to focus on simplifying the function. We have an x minus 3 on the top, and we're going to focus on the denominator here. So this is a 1x minus 1/3. Our common denominator is going to be a 3x. We have 3x on both sides. Well, what do we need for this to be a 3x? Well, multiply top and bottom by 3. So we have a 3 over 3x minus, what do we need here? An x, right? And then what are we going to get? Well, after this point, we can, once again, let's write this top here. We can put them all together. So we're going to have a 3 minus x all over 3x. And you know, when you're dividing by a fraction, you can simply multiply by the reciprocal. So we're going to have an x minus 3 times our, let's put that over 1, times 3x over 3 minus x. And if you want, you can make this all one fraction again. So you have an x minus 3, and you have a 3x, and you have a 3 minus x. Now, how do we cross out anything? We're very close to crossing out something, but we're not quite there. Here's an x minus 3 times 3x, and we have a 3 minus x. These don't necessarily cancel out right away. What do we have to do first? We need to factor out a -1 from one of these. So let's factor it out from the bottom. And to do that, we're going to be getting an x minus 3 times our 3x, and we have a -1 times our x minus 3. Now we can cross out what's in common, which is going to be that x minus 3, which gives us a -3x as our final version of this function. Our simplified version of x minus 3 all over 1 over x minus 1/3 is going to result in -3x being its final form. That means that we can simply rewrite this limit as the limit of -3x. So we're going to erase this and say that our limit here is going to be the limit as x goes to 3 of -3x. And when we plug this in, we're going to check for continuity at the point. We're going to see that we're going to have a -3 times 3, which gives us a -9. And just like the last example, this is a removable discontinuity, thus a hole. That means that this function is going to look just like this function everywhere except at this point 3. There's a hole there. So we can simply find what this is going to equal at 3, and we know what the limit of this is going to be as x approaches 3. This is going to be our final answer for this problem. Let's move on to our final example for today, which is going to use our conjugates. In this last example, we're going to be using our conjugates to simplify this function. Now, just like we did in our previous two, if you were to plug in the value checking for continuity, you would notice that we got 0 over 0 once again. Indeterminate form. We have to simplify this. So we can kind of skip that step and move into how to simplify. Now, why would you use conjugates here? What will let us know that we probably want to use conjugates? Well, if you have a radical in your function like this, then you're probably going to want to use conjugates. That's going to be a little hint. I'm not going to say every time, but probably most likely you're going to be using a conjugate if you see a radical in your function. So because we have this radical here, let's use our conjugates. So we're going to multiply top and bottom by the conjugate of the numerator, which is going to look like this. Once again, I'm not going to write the limit until the very end. I'm focusing just on the function. So we're going to have the square root of x minus 3 times the square root of x plus 3 all over x minus 9 times the square root of x plus 3. Now we're going to simplify the numerator. Now we're going to leave the denominator as it is, and you'll see exactly why. We're going to simplify the numerator first, and to do so, we're going to multiply everything across. And one of the special properties of multiplying by conjugate means that we don't have any middle terms. We can just focus on the first and the last term. So this is going to be a square root of x times square root of x, leaving us with x, and we have a -3 times a positive 3, which gives us a -9. Now we have x minus 9 over x minus 9 times the square root of x plus 3. Now you see why I didn't want to do anything to the denominator first, because we are going to cross out what's in common in the top and the bottom. Your x minus 9 goes away, and you're left with 1 over the square root of x plus 3. Now, we don't really like to have radicals in the denominator, but it doesn't really matter in this case. And that's because we want to see, are we continuous at this point 9 for this function? If we are, we just want the value, because that's going to be our limit. So we can rewrite this here, this limit up here, to be the limit as x goes to 9 of 1 over the square root of x plus 3. And when we do that, plugging in our 9, we're going to get 1 over the square root of 9 plus 3, which is 1 over 3 plus 3 gives you a 1 over 6. So 1/6 is going to be the limit of this function. Remember, this is a hole, a removable discontinuity. This is going to act just like this everywhere except for 9. At 9, it doesn't exist, but this one does, so we can use this to figure out what is this approaching our limit at 9, which is going to be 1/6. And these are 3 different modes of simplification that you most likely have to employ when you're trying to simplify your indeterminate form. So I hope you were able to follow along with today's video, and I hope you also understand how to simplify your limits. However, if you have any questions about what you see today, or even on homework, you can always put in the comment box below, or visit my Facebook page at Tutor Me Sempai and tell me all about it there. If you hadn't done so already, remember to leave that like. It surely helps the channel by letting YouTube know that you found a video helpful. And if you found a video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share the video with a friend. Well, that's all the time I have for today. I'm really hoping this helped with your homework. I'm looking forward to seeing you again next week. I'm Courtney. Here's your playlist, and this has been another session of Tutor Me Sempai.